So let's look at some examples to practice with this shortcut rule. That is, I've got two logarithmic functions listed here. One of them has the natural log with some function inside. And the second one has logarithm of 3x. Again, remember there are two special kinds of logarithms. One of them is log base e, which we call the natural logarithm, or ln. And the other one is, well, if we see log without anything written, then we assume that's logarithm base 10. Okay? So that means I've got logarithm base 10 here. So let's go ahead and compute the derivative of both of these. So again, using our shortcut rules, remember that if we have the natural logarithm, the derivative is simply going to be the derivative of the inside divided by the actual inside. Okay? Using the chain rule, of course. So look, this is my inside function right here. I can identify it as x squared plus 5. So remember, by the shortcut rule, the derivative of the inside goes on top of my solution here. So therefore, the derivative of x squared plus 5 is, of course, 2x, right? And then I just divide by the actual inside function, which is just going to be x squared plus 5. So there's my solution, 2x over x squared plus 5. We can't simplify any further. And of course, similarly, we can differentiate the function g with respect to its input x. Again, we use the same property. Remember that for the more generic version of logarithms, the shortcut rule, we do the exact same thing, except now, instead of the derivative of the inside divided by the inside, we also have to include the logarithm of the base. Remember that? So down here on the numerator of my result is going to be the derivative of the inside. Well, the inside we can identify as 3x. So this is the inside. Well, the derivative of the inside is going to be the derivative of 3x, which is 3. So there's a 3 up here. And remember that we simply just divide by the inside function itself, which is clearly 3x. And of course, we also have to include down in the denominator the natural logarithm of the base. But of course, the base in this case is 10. Now again, keep in mind that this is the natural logarithm of that, so that's kind of together. So I can't really cancel anything with the 10, but I do notice there's a 3 multiplied by all of the stuff in the numerator, and there's a 3 multiplied by all of the stuff in the denominator. Those cancel. And so if I simplify this second expression, I finally get 1 over x natural log of 10, right? Natural log of 10 is going to be some number. So ultimately now I've, by using the shortcut rules, come up with the derivative of both f and g.